Welcome everybody, and thank you for joining us for the Climate Adaptation Research for BC Agriculture Virtual Workshop. My name is Serena Black, and I am the Agriculture Extension Specialist at the University of Northern BC, and currently I am sitting as chair of the BC ACARN. I'm very grateful to have had the pleasure of working with this network for many years now and to being able to start off our virtual workshop this year. I am hosting this session today as a guest living on the traditional, ancestral, and unceded territory of the Lheidli First Nation. This is our second year of hosting this workshop virtually, but the first adaptation research workshop hosted by the BC Agricultural Climate Adaptation Research Network actually took place back in February of 2016. Back in 2016, we had 38 people come together for the day to discuss adaptation priorities and research directions. And since then, this workshop has become an annual event, and we actually have over 500 people registered over the next 3 days of sessions. The main mission of the ACARN Research Network is to increase collaboration between researchers, industry, across regions, across disciplines, and across institutions, so that we can better meet the research and extension needs of the BC agricultural sector as they adapt to climate change. After the year of extreme weather events and wildfires that we have seen in British Columbia, the need for urgent, coordinated, and collaborative approaches to addressing climate change challenges and supporting the agriculture sector could not be clearer. This provincial workshop is an important opportunity to foster dialogue, encourage networking, and discuss current research. So to encourage some of that virtual networking, I see we've had a lot of it already. I do invite you to introduce yourself using the chat box and to please share where you are joining from and why you have joined today. Make sure to use this feature throughout the webinar to connect with each other as best as possible in this virtual world we are currently living in. Each day throughout this virtual workshop, we will begin with a 1-hour webinar featuring 2 speakers who will be sharing their research on key topics. Today, we'll be discussing extreme heat, tomorrow, wildfire, and then on Thursday, we'll jump into carbon sequestration. We will then take a half-an-hour break before logging back into the Zoom file for a 90-minute panel that digs deeper into this morning's topics. We would like to acknowledge the generous support that has made it possible to host these workshops annually. So funding for this week's workshop has been provided in part by an anonymous donor, as well as in part by the governments of Canada and British Columbia under the Canadian Agricultural Partnership, a federal provincial territorial initiative. So to get started, we have 2 excellent speakers today who are going to be discussing extreme heat and drought events that we've experienced this summer in British Columbia. While those events may now, perhaps to some, seem pretty distant, the impact of that extreme heat and extended drought are part of why the recent extreme rain events have caused so much damage and disruption throughout our province. After each presentation today, we will have a break for a Q&A, so please type your questions into the Q&A box instead of the chat. It's a little bit easier for us to keep track of it that way. And you'll also, so you'll be able to find the Q&A tab at the bottom of your Zoom control panel next to the chat box, I believe. And it's in the Q&A box that you can also upvote other people's questions by clicking on that thumbs up symbol. So by clicking on that symbol, the more votes a question will get, it'll move it to the top of the queue and will help us determine which questions we'll be able to answer here today. Another note in this virtual world, if you notice me going like this, this is the ASL, American Sign Language for applause. So I've gotten very used to using this in these webinars. So if you see me doing that, that is what I am doing. And without further ado, I'm happy to introduce our first speaker, Faron Anslow. So Faron is a climatologist who leads the climate analysis and monitoring theme at the Pacific Climate Impacts Consortium, where he characterizes BC's climate history and extreme events in the context of climate expectations. Welcome, Faron.
Thanks, Serena. Yeah, it's a pleasure to be here, and I'm great. Really glad to see so many people in attendance. You know, this is a, no pun intended, a hot topic these days. And I think I can maybe link us from the heat wave to the rain event that we saw this year. So I'll just jump right into my presentation here. Just going to share my screen. All right, I hope people can see a presentation up there, analysis of the June heat wave. And when I first started talking about this, you know, I was swept up into a research effort to try to understand the heat wave and also do an attribution study to try to see if and how much it was linked to climate change, the amount of climate change that we've seen. And in looking at the event, I noticed that atmospheric rivers may have played an important role in forming the June heat wave. So I put the subtitle into some other talks that I've given, and unfortunately, it's turned out to be very prescient going into what we saw in November this year, and the flooding is still receding as we speak, as you all know. So, you know, I have my name here, but this work is on the shoulders of a large community of international researchers that have looked into the heat wave. I'm just going to minimize this here. So the World Weather Attribution Group, as well as colleagues at the Pacific Climate Impact Consortium. So just jumping in, the brief outline here is, you know, just looking at what happened with the heat wave, a little bit about why it happened, and then trying to answer the question, was it climate change, or how much of the heat wave was climate change? And then what does this tell us about our future? Does it change how we think about heat waves going into our future and our future planning? You know, very quickly, it was greatly influenced by climate change, and climate change is going to make it worse. You know, in the future, we can expect these events to happen quite frequently. So the TLDR here is, yes, this is a problem. We need to plan for it. So what happened? This is a map of the locations where records were set using a gridded reanalysis product, looking at North America. The deepest reds are places where the highest temperature ever observed in the 1950 to present context was observed, and then the less red colors are where the second, third, and fourth hottest temperatures were observed. And what this highlights is that the event was really region-wide. It was almost all over BC. Just the northwest corner may have escaped the worst of the heat. It was down in Washington, down in Oregon, and then all the way across the northern prairies, Alberta, even into Northwest Territories and Yukon. So a huge event, kind of carved a swath of heat. The heat dome made its way across the province over across the country over subsequent days. So really a big immediate impact of the event. And looking at the weather station data, what I'm showing here are the places where records were set. So on the left, it's the temperatures of the record T maxes that we're seeing, so the record daytime highs. And on the right-hand side is where the record warm overnight temperatures were seen. And the size of the symbol that's plotted is scaled with how large the record break was. So the largest symbols are about 6 degrees, and then it vanishes to 0 if the record was just barely set. And so you can see this kind of center of action. So the largest symbols are kind of plotting around the Lytton area into Kamloops, but also very large record breaks all throughout the Okanagan, where obviously agricultural activities are very prominent. And also very large overnight temperature breaks in that same area. So the nighttime temperatures were very warm, upwards of almost 27 degrees for an overnight low. Really important for human impacts in terms of just physiological recovery, and I'd suspect the same might be true for agricultural practices as well. Like when you have those warm nighttime temperatures, things don't relax back to get a chance to recover. So really a widespread heat wave event all over BC with just absolute shattering of temperatures. And as we all know now, setting the new national highest temperature ever recorded in Canada of just under 50 degrees centigrade. The heat continued throughout the summer. So what I'm showing here are the seasonal rankings of T max on the left-hand side and T min on the right-hand side. Just showing, and these are averaged over hydrological basins, but just showing where over the long seasonal point of view, the temperatures got hot in June and stayed hot. So record-breaking temperatures again in the Okanagan, and a little bit around Prince George. There's again a lot of agricultural activity in that area as well, or some. And with the overnight temperatures, just really again crushing the records for warm overnight temperatures throughout the entire season. And right along with that, it was very dry, and that helped bring about the wildfire season that we saw. So dry all over southern BC. Storm tracks were directed to the north, so northern BC saw some more moist conditions. And the impacts to that are of the heat wave itself are pretty well known now. There's direct infrastructure impacts, roadways buckled. I've heard anecdotal stories of people's windows breaking in their house as structures expanded and flexed under the heat. Huge marine die-off. The tidal swings were at their annual largest, or just about, and the low tide in the Salish Sea coincided with some of the hottest temperatures, so it exposed a lot of marine animals to heat without the cooling benefits of the water. As we know, Lytton largely burned, and that's kind of the kickoff to a really strong wildfire season. And as everyone here knows probably a whole lot better than I do, there are really direct impacts to crops from the heat wave, and then ongoing impacts with the hot, dry conditions that we saw. So just a brief list. I've already talked about a lot of these. Many thousands of people were struck with heat-related illness. I think the number of deaths associated with the heat wave in BC is, excuse me, is approaching 750 when looked at excess death from an excess death point of view. The impacts were disproportionate. I have yet uncounted losses, but I'm sure by now, people have taken stock of the losses that they suffered during the heat wave and the ongoing summer heat. And then the question, of course, remains what the knock-on effects are going to be as we go into the coming growing season. Huge impacts to energy demand, wildfire, and then a loss of cryospheric resources. So the remaining snow that was there melted rapidly. Glaciers took a really big hit. So what happened here? What we have here is just a satellite image of the Western Hemisphere. So North America is up at the top center there, and there's a giant hole in the clouds underneath the so-called heat dome, just letting in a lot of solar radiation, a lot of energy to heat the surface. at the time of the year where the days are the longest. So lots of energy coming in that way. Is very dry in southern BC leading up to the event. This dryness extends down into Washington and Oregon. There was a really brief rain event about a week before the heat wave. Again, another atmospheric river. So it kind of put a skein of moisture on everything west of the mountains, at least. But I don't think it was enough to mitigate the amount of evaporation that was going to occur over the several days of the heat wave persisting. So these dry conditions, they prevent or they disable the evaporative cooling that helps mitigate some of the energy influx during the summertime. And without that cooling effect, the air temperatures are able to go up those additional several degrees. Extremely high atmospheric pressures. So this is a time series plot of what's called the 500 millibar height. So just a way of measuring the strength of what we're calling the heat dome over the period from 1950 or through June anyway. And in black is the average over our region, and in red is the average over Western Europe in 2019, at the time when they had a very strong heat wave as well. And we set, at least for these latitudes, or not only set, but really shattered the record for high pressure strength of the ridge over us. And when you have those ridges of high pressure, it forces air to subside underneath the ridge, and that subsidence generates heat and adds to the heating effects. And then there's a lot of water vapor. If this video loads, this is an evolution of how the weather kind of progressed from mid-June all the way through the heat wave, looking at it from an atmospheric moisture point of view. So the brown colors are really dry air. The lighter gray colors are very moist air. And what we see starting out is this atmospheric river hitting southeast Alaska. Produced quite a lot of rain, not in areas where a lot of people live, so the impacts were very minimal. But I'm just going to show that video one more time. But that moisture, it leapt over the mountains and then it got stuck under the heat dome, and very likely provided a little bit of additional greenhouse warming. That water vapor is a pretty strong greenhouse gas, and that probably helped establish those really warm overnight temperatures, where the water vapor is preventing the cooling off that happens on a clear summer night on a typical day. So to answer the question, if it was climate change, we have to go at this with a broad set of tools, looking at the weather station data to get a sense of the historical comparison of the heat wave event to previous heat wave events, or just typical annual hot temperatures. And then a lot of data from climate models is used to compare these hypothetical pasts and our projected future. And the hypothetical past is basically trying to answer the question of what would have happened if we didn't have greenhouse gases in the atmosphere. So allowing everything else like solar variability, volcanic eruptions, various other natural sources of climate variability, but without the greenhouse gases. And when you compare the evolution of temperatures in the hypothetical scenario to what actually happened, you can get a sense of how much of the warming and how much of the heat wave was due to our anthropogenic contributions to greenhouse gas, to the greenhouse gases and global warming. And then going into the future, we were able to use these models to project climate change and see how much additional warming we're going to see and how much that influences how often we see heat waves of this magnitude. So looking at the station record, the plot in the top right, it's a record of the hottest temperatures from each year. So you just pick out whatever the hottest Tmax was. And when we plotted this data, this is going back to data from the late 1800s, a couple of gaps, but really capturing some of the hottest previous events. There's one in 1940, 1942. What we see is the heat waves kind of varied around this kind of expected level, and then the event of 2021 just really leapt out of that expected range, bringing us up to, in Vancouver, the low 40s. And when we fit an extreme value distribution to that data, we're able to compare that distribution to the historical with the distribution of the present day, and get a sense of just how much more likely the amount of climate change that we've seen has made this event. So from this particular record, we see a 4-degree record break. The extreme value analysis tells us this is a 1 in 1,000 year event. And then the amount of climate change that we've seen has made this 170 times more likely to have happened. So that's just comparing the late 1800s to now. And furthermore, the amount of climate change that we've seen, so globally, we've seen about 1.2 degrees of temperature increase, but the heat waves have become as much as 3.2 degrees warmer. This particular event was likely 3.4 degrees warmer than it would have been in the pre-industrial. I performed a similar analysis for Lytton, and we see a very similar result, more extreme even. So again, a massive record break for Lytton of 5 degrees. There it was an even more rare event. And the amount of climate change that we have seen has made this event up to 270 times more likely than it would have been in the pre-industrial. So we can do a similar analysis with the climate models using that hypothetical versus the actual evolution of the atmosphere. And the benefit of that is we get a lot of data to work with, so we can have a bit more confidence in the numbers that we arrive at. And what we find is that the event was, this agrees with what we see in the observations, but the amount of climate change that we've had has made this event 150 times more likely and about 2 degrees hotter than it would have been in the pre-industrial. Interestingly, so that 2 degrees hotter still leaves about 3 degrees to get to the hottest temperature that or the largest record breaks that we've seen. So there's, global warming is a part of the signal, but there's also just the variability of the atmosphere to get us to that full 5-degree record break. And then as we warm an additional, roughly a degree, 0.8 degrees, these events are going to become much more likely. So it's happening as often as 1 in 5 years to 1 in 10 years. And the climate projections under most scenarios, most likely scenarios, show that we'll get to this 2-degree level at around the 2040s or so. What does this tell us about our future, and does it change our thinking? Yeah, it tells us this is still a result of rare circumstances. It'd be very unlikely to happen again if not for climate change. With climate change, it's very likely to happen again before the end of the century, most likely by the middle of the century. And it changes our thinking in that we may need to look at how we assess heat waves and the antecedent conditions that may exist to contribute to them. I think I'm running a bit low on time, but right about this time that the time that the heat wave happened, there was a paper going through review that was looking at basically exactly what we saw. So this case where we have basically a static record of annual maximum heat. So very little trends. The records that we do set are only marginally larger than the records that were previously seen. And then suddenly we get these kind of these earth-shattering record breaks. So this plot here is taken directly out of a climate projection. So including the historical run all the way through looking at future climate. And this just happens to be in central United States. And it shows exactly what we saw with the BC heat wave. Fairly untrending time series of records, and then all of a sudden this massive record break. And the take-home message here is that happens because when we're assessing the likelihood of events, we only have the records, especially if we're doing it with station data, we only have the records that were given or that are available to us. And there's a pretty good chance in a lot of locales with a rapidly changing climate that we just haven't by chance yet seen the big heat wave. And so our return intervals are going to be too low. They're set up for a historical climate that just doesn't really apply anymore. And so that's kind of the way we need to think of the future, is that the return levels that we've established for ourselves are rapidly becoming obsolete as climate changes rapidly from underneath us. I'm going to skip ahead here. This is a result from that same paper, just showing the likelihood in any given year of a major heat wave happening. But it shows the variability. Tells you, there are locations on Earth that haven't seen a major heat wave recently, and they're in a sense due. So when they finally do get the heat, it's going to appear like a very extreme heat wave, even though it's fitting with the amount of global warming that we see, or that we've seen. What you can see here is there's a bit of high likelihood around BC and also in kind of central northern Canada, showing that our recent past hasn't seen a lot of heat waves, and we're kind of in this state of being due for a major event. Granted, this was before the heat wave that we saw, and now we've achieved that event. I think I'll leave it there. I think we just need to have time to answer some questions. But if people would like, and if we have time, I can go into talking about a bit about the atmospheric river that we just saw. So with that, I'll stop sharing and hand over control.
Thank you, Faron. It's to see the actual data and the records, and whether we're breaking the 1,000-year, or I think it was the 6,000-year kind of event, and even just between, I think that was between Vancouver and Lytton. It's, a very pertinent topic, and perhaps we'll have time to move into that. I will just start my timer here to make sure. We'll ask a few questions now, and then if we need to go a little bit after 10 to do some follow-up, we can. So actually, the first question that was upvoted was based on the last few graphs that you said you were presenting on. Where was that? Could you clarify where that data from the graph came from? Just kind of noting that it's a pretty huge span between the 1850 to 2021.
The data for Vancouver, that came from it's actually, so it's a data set called the AHCCD, Adjusted Homogenized Canadian Climate Data Set. That's produced by Environment Canada. That particular record is two stations that are conjoined. It's New Westminster and Pitt Meadows area. And some adjustments were made to the data to get those stations to agree in the period that they have overlap. But yeah, it is a problem with this kind of analysis, is it is hard to find long records from a single station that hasn't seen big changes. So that's where that data came from.
Okay, fantastic, thank you. We have some questions that are a pretty big picture and perhaps out of your scope, but one of the first questions that came in was the comment of, it seems like most living creatures can adapt to change. However, there's concern that fish are not one of those creatures. Can fish keep coming up? This was specifically to the Shuswap, to their spawning grounds, to complete their life cycles with those temperature increases. I know you're not a fish biologist, but any comments there in terms of the work that you've done?
Yeah, I've just chatted a little bit with the people that study salmonids. Yeah, I don't have a ton of information other than by the end of the summer we did see very low flows, and low flows combined with hot temperatures lead to very warm water conditions, and that's really hard on the fish. I think it's an additional question what the impacts of the flooding are going to be. So the fish that have made it up and were able to spawn, a lot of those spawning grounds have been changed a lot by the flooding, at least on this side of the mountains. Yeah, I think we'll only know the impacts when we start to look at fish counts from the hatched fish that are transiting back down to the ocean. In terms of salmon, in terms of other species, yeah, it can't be good, but I don't have any authoritative answers for that.
Yeah, and the maps that you were showing, it did show that extreme heat kind of in the Prince George, Nechako Valley area, and maybe relating it to what we can do in agriculture. I know there was a group in the Nechako Valley area that were measuring temperature waters along the stream throughout the heat wave in both areas that had very healthy riparian zones along those streams, and then areas where the fields matched right up against the stream. And it was a 10-degree difference. So it was 10 degrees cooler in the stream waters where there was healthy riparian areas compared to going right against, having the field go right against. So that maybe those are some adaptations, mitigation efforts that we can do in agriculture to try to protect those areas amidst all these changes. So I'm going to do one last question, and we'll try to maybe type in some answers fair into the ones after that. And if we have time, we'll catch some more at the end. But for our last question, there's a comment from Peter. So north of Fort St. John, BC, on the heel of the heat wave, we experienced a very severe thunder and lightning, hail, rain, wind event, and it was dubbed a bow echo storm. Winds in the area were confirmed at 190 kilometers an hour.
Wow.
Should we expect to see more storms like this in the future if future heat waves occur? And is it normal that this would occur at the end of a heat wave?
As far as it being normal to occur at the end of a heat wave, I think it is quite typical. That is the typical course of a bad wildfire season is you get these ridges of high pressure. And when that ridge breaks down, it's usually because some cold air and a low pressure system comes in behind it. In the summertime often generates a lot of thunderstorm activity. If there's not a lot of moisture with it, then there's going to be a lot of dry lightning. So that sequence of a big ridge breaking down with a heavy thunderstorm is common. With climate change, it's a tough question because convection. So convection is a process that generates thunderstorms like this. It's not particularly well resolved in climate models, but the ingredients are all there. So particularly with this event, there's a lot of moisture in the atmosphere, and that's one of the contributing factors for generating thunderstorm activity. So yeah, so a bow echo storm is one it's particularly well organized. So they're particularly strong. We have a signature on the radar that shows good organization that allows the strength to develop. But yeah, whether or not there's going to be more of those with climate change, I don't have the answer for that. Sorry. But the ingredients will be there, like the heat, moisture, and potentially the rapid changes from one to the other will be there.
Yeah, a lot of different principles kind of all working together. Wow. Well, thank you, Faron, for your presentation, getting this discussion started. There's a lot more questions we can get answered to right now. So perhaps if there's any that you could answer really quickly by typing in an answer, we'll go there. And or follow up with some answers following the webinar. But thank you for the presentation.
Thank you.
And and it is silly, but it actually gets it feels odd not to clap, so I do enjoy that. So now moving on to our second speaker, I would like to introduce Trevor Hadwen, Agroclimate specialist with Agriculture and Agri-Food Canada's National Agroclimate Information Service. Trevor leads a variety of climate monitoring, assessment, and reporting activities, including the Canadian Drought Monitor. Trevor's work includes a long history of development of extreme climate indicators and assessment tools that help anticipate and mitigate the impact of extreme climate events. Welcome, Trevor.
Just thank you very much. I'm hoping you can hear me okay, and you can see my screen in just a second here.
Yeah, we can see the screen. Oh, we might just want to switch the views. We're seeing the presenter end of it.
Give me a second.
There you go.
Seeing the right one now?
Yep, that's full screen. Thank you.
Okay, great. And thank you very much again for having me at this meeting. I'm here to share a little bit of information on the 2021 drought in Western Canada. And with that, I'll talk a little bit about the heat dome as well. It's hard to separate the heat dome issues from the drought this year because they kind of go hand in hand. And so there'll be a little bit of repetition and additional information on the heat dome throughout the presentation here. So let's just jump right in here. So the 2021 drought presentation, I'll provide a little bit of information. I'm going to be talking a little bit broader scale than just British Columbia. I'll talk a lot about Western Canada in general. I'll try to make it as specific to what British Columbia as possible, but again, to provide the context of where we're looking and how big an event and then how unprecedented this event was, I'll expand that out from British Columbia. We'll talk a little bit about what made this drought different, the impacts of the drought, the heat wave, and specific impacts there, and how does this compare to other droughts throughout the last number of years. And then finally, I'll end up with some current conditions and possible implications for 2022. So as was mentioned, I work with the Canadian Drought Monitor quite a bit and lead the team through that process of making monthly assessments for drought right across Canada. Agriculture Agri-Food Canada is the agency responsible for federal drought monitoring throughout the entire region of Canada, despite our mandate basically being agricultural regions. We do drought assessment in all regions of Canada with the exception of Nunavut. This past August represents the largest extent and most severe drought conditions since we started doing the drought monitor process in 2003. So again, we've had 18 years of drought assessments in Canada utilizing this process, and this one's by far the most significant and most severe drought right across Western Canada. At its peak, drought covered 94% of the agricultural land in Western Canada, 28% of that being extreme or exceptional drought. And that represented 46 million acres of cropland, 54 million acres of pasture, and over 2 million cattle throughout Western Canada. On the bottom of the slide, you can see a kind of a time graph of how drought has progressed through the last 20 years, and looking at where we see those reds and darker oranges on the map. Those are our extreme and exceptional drought classifications. You'll notice that there's very few of them, and we've gone through a fairly wet cycle in Canada through the last 20 years, with some periods of drought. Obviously, large drought in 2000, 2001 led to us creating the Canadian Drought Monitor process, modeled after the United States' process. And then there's some small little peaks of exceptional and extreme drought in 2009 and a little bit in 2015. But really, this is by far the most extreme situation that we've had in the past 20 years, with exceptional or extreme drought covering more than 25% of the area of Canada. So to put this in context a little bit further, again, the drought wasn't just a Canadian drought, it was a large North American drought. So this is the North American Drought Monitor. We partner with the United States and Mexico on creating this product to ensure that we have a full comprehensive drought response for all of North America. We utilize similar processes to create our products and merge them together into one product. So in terms of the 2021 drought, 30% of the land area of North America was affected, including 20% of the population. The Columbia Basin, which extends into Canada in Western Canadian region, 96% of that area was covered by drought, and 52% of the Great Plains. Which was mostly all of the northern Great Plains impacted. So when you look at the total area for North America, obviously there's been some more significant droughts through the years, including 2011, 2012, 2013. Those were all droughts in Texas and the southern US. This one ranks right up there in terms of total area of those very severe droughts in about 10 years ago that occurred all throughout the southern US. Actually, in 2010, 2011, 2012, Canadian drought was at one of the lowest on record. So we had very little drought during those really dry years in the US. But this year, we're looking at very dry conditions throughout that whole western region of both Canada and the United States. Okay, so just talk a little bit about how this drought developed, and one of the key pieces that I'm going to talk about is how the drought in BC developed differently than the drought in Saskatchewan, Alberta, and Manitoba. So going into last winter, we saw very dry conditions starting to develop in the prairie region. especially in Manitoba and eastern Saskatchewan. We saw very low precipitation, very low soil moisture, and a lot of concerns started popping up in terms of potential drought for 2021. And as we moved through the winter period, that concern only heightened. We ended up with very low snowpack throughout the winter period and a very early spring. Note on our maps here that British Columbia actually has a fair bit of moisture both in the fall and the winter. We saw really good snowpacks in upper elevations. We had good soil moisture, good stream flow, all those type of things going into last fall. So the drought that we happened this summer, actually, if we look at how British Columbia is set up for the year, it could have been much worse going into the year with a drier fall and a drier winter, which is not uncommon during the winter period in British Columbia. So one of the things that happened this spring, so we saw a very big switch in terms of where the rainfall was occurring and where it wasn't. British Columbia started to receive extremely low precipitation in the spring, causing drought concern right off the bat. In the prairie region, we saw, again, very early spring, very low snowpack, so that all melted really quickly, low stream flow and runoff from that snowmelt, and exposed soils throughout early spring, losing a lot of moisture during that period, which typically would have snow cover on the soil and protecting that from moisture loss. Now, when I talk about how the heat wave and the heat dome affected the drought, we got to kind of look at where that was. And again, when we look at the extreme heat over Western Canada, it happened very early in the year. Heat waves do happen occasionally, and they're part of our record, but they typically don't happen early in the season for agriculture like they did. So late June, early July is very unprecedented in terms of the record temperatures or the amplified the temperatures that we received, and that caused significant problems in addition to the dry conditions that we saw. So the heat dome at its peak again stretched from Vancouver Island all the way to Manitoba and Northwest Territories. Again, we've heard that resulting in record temperatures, and saw some really good graphs on that in the last presentation. In total, 135 all-time maximum temperatures were hit, not just in British Columbia, but in Saskatchewan and Alberta as well. And one of the other key factors for agriculture is that our overnight low temperatures did not drop. So we hit over 100 minimum temperature records throughout Western Canada as well. That impacts our crops as well. So we did not have those overnight low temperatures that kind of provide that recharge and refreshing period for a lot of crops. Just on the heat wave and heat dome again, just a different look at it. Number of consecutive days above 25 degrees, basically until July 18th. So we had over 16 days in much of British Columbia there in the interior regions of BC, with very warm temperatures for multiple day periods, so over 2 weeks in a row. So that is one of the big causes. And we talked about the record being set, but I don't think we acknowledged how big of a record that was. Like, we're 4.6 degrees warmer than the previous record, which was set in Yellowgrass, in Midale, Saskatchewan, almost 100 years ago. And so Midale and Yellowgrass is an interior continental landlocked area where we expect warmer the temperatures. We certainly don't expect close to 50 degrees temperatures in Western BC. So that's an incredible stat. not only did they beat the record once, they beat it multiple times in that period, and they actually beat Las Vegas's high record by a couple degrees. In addition, not only Linton broke the record, but Kamloops broke it 3 days in a row. Cache Creek broke it 4 days in a row, and multiple other stations as well. So again, this was a hugely unprecedented event, causing significant impacts both to agriculture and multiple other sectors. As we look at some of the impacts, we talked about all these, or a lot of these already. I do want to highlight a few of them. And being an agricultural specialist, I'll start there. In terms of number of deaths of breeder hens, we had 30,000 breeder hens die, over 143,000 leg hens die, 61,000 turkeys, 400,000 boilers. Egg production was reduced by 70% during this period, so very significant to the poultry industry. Heat and dehydration affected the dairy herds. Milk production dropped 17%. Berry crops and fruit, significant impacts again. Crop losses range from 20 to 60% on raspberries, 10 to 40% on blueberries, and apple orchards experienced a lot of leaf drop and scalding and sunburn, and production potential dropped by over 50%. One thing that we need to note is the impacts of this heat wave are still being felt. Again, we've seen heavy rains and the atmospheric rivers, both in September and November here. The soils have been dried out so much that they're hydrophobic and they don't want to absorb any moisture, resulting in a lot of landslides, as well as not providing moisture percolation into the soil and resulting in more significant flooding than we would have expected. The forest fires that we saw also earlier in the season have amplified the flood risk and everything else related to what we've seen over the last month in British Columbia, and still relates back to that heat dome from earlier in the year. I want to switch gears a little bit into British Columbia and looking specifically at one of the programs that we work on, which is called the Agriclimate Impact Reporter. The Agriclimate Impact Reporter is a tool for the collection and reporting of agriclimate impacts that result from weather and climate events across Canada. This tool enables Agriculture, Agri-Food Canada to better understand the local and regional effects of weather and identify emerging risks. So these come from volunteer reporters. It's completely anonymous. And over the course of the summer, we had 243 reports of drought issues related to British Columbia. So this was really good, and I thank all our reporters within BC for providing this information. It again provides a lot of details in terms of the actual impacts of the weather and information for us to help make decisions, and goes towards policy and program decisions as well, supporting multi-million-dollar programs. So again, this citizen science information is extremely valuable and very easy to provide. If you're interested in providing that, the link is on the below the map there. Just sign up as a reporter and we can gather your information on them. We do it on a monthly basis on a number of things. A very quick, easy 3 to 5 minute survey provides us with a great deal of information. So these are some of the maps that come out of the information provided by our citizen science reporters through the AIR network. So one of the significant impacts of the drought this past year was feed availability and pasture conditions. So we map those and asked very specific questions on those to our producers. So when we look at the runoff and limited precipitation resulting in poor pasture conditions and range conditions, we saw a 50% reduction in hay yields and shortages that are estimated to be about 6 million tons at this point. Again, water supply issues throughout much of the prairie region and some parts of British Columbia as well. Again, we're looking at significant water supply shortages, and then the crop hit substantial reductions as well of 35 to 40% compared to the 2020 crop yields. We also saw larger than normal herd reductions, 10 to 20% in that range, depending on what measures you're using. Increased prices for most crops, some of them at all-time record levels, especially some of the specialty crops. And then we've talked about the wildfires throughout many of agricultural regions, resulting in grazing losses and forcing relocation of livestock as well. Total crop indemnities for the year related to drought are over 5 billion, which is a record at this point. 29 million in British Columbia alone. So just very significant crop insurance payouts for drought relief this year. Just some very specific impacts reported from the AIR network. So these are comments directly from people in BC that provided us with information through the Agriclimate Impact Reporter, and provides us again with very significant information and some early warning on what's happening on the ground in these various regions. So in May already, we're seeing reports of poor rainfall, large gaps of or large extended dry periods, cattle still being fed, not grazing pasture, very late in the season, cracks forming in higher elevations with dry conditions again. And then in June, a lot of the discussion was around heat and how that impacted their specific operations, some of them being greenhouses and one of them being the pepper production, resulting in a lot of cull of peppers due to high heat. Dairy sales, again, reduced, significant damage and losses to some of the nurseries and potted trees, and all that. So that's long-term effects of how we replenish some of the stock into the next year. Again, another report of losing 90% of his flock of turkeys. So basically losing 8,000 turkeys there during the heat wave. And then finally, so many grasshoppers, so dry, kind of sums up the season for a lot of people. So again, these comments, we get, again, multiple comments on a monthly basis from these reporters, and they provide a lot of insight into what we look at from a reporter and assessment point of view. So I want to take a quick look on how this drought compared to other droughts. So we do have a history of record of droughts, and thanks to Elaine Wheaton and Barry Bonsall and others that did a great study in terms of looking at historical droughts through the last 100 years of where and the severity and extent of droughts. So we can see that the 1930s and the 40s were fairly dry years with some very extremes in there. We got 2001, 1988, 61 in there. And we obviously don't have 2020 in here or 2021 in here because the study was done previous to that. But we can look at the data that was used in the study, which was Standardized Precipitation Evapotranspiration Index, 3-month. And we can look at a date from this past summer and look at how dry conditions are in this map. So the black is the driest condition, going through browns, reds, oranges, and whites are closer to normal conditions. So in 2021, standardized precipitation and evapotranspiration index covered approximately 80% of the prairie agricultural region, and more so in British Columbia. It's the largest extent and severity of drought since 1961. So again, we're rated somewhere in the area of 80%, whereas 1961 was about high 80s in there. I don't have the paper in front of me, so I don't know the exact number there, but well over 85%, closer to 90% in 1961. So when we look at those specific drought years, so this is mid-August, looking at 61, 88, and then this current year, we can see on this indicator very significant difference between what happened this year and what happened in those previous other extreme drought years within our lifetime here. So 1988, extremely dry conditions, but also very wet conditions in the Western prairies and into BC. 1961, larger area of dryness, but again, we did have some areas of wet, which represented by the blue. In 2021, we saw very dry conditions over the entire region of Western Canada. So that's kind of unprecedented. We haven't seen a drought like that in a very long time. Even in the 30s and even the 50s, where we saw very large drought periods, we see 1 year being dry for Western Saskatchewan and one dry being wet for that area. So it kind of, but the drought moved around and bounced around a little bit and accumulated over time. Looking at a 1 year drought, this is one of the largest and most severe droughts that we have on record.
So Trevor, I'm just gonna jump in. Maybe if we have a maybe quick wrap up as we are reaching towards the end here.
Yeah, absolutely. I'm on my second to last slide here. So this is just the current drought situation. I won't talk about it much other than the fact that we have seen very significant rain in parts of British Columbia, as you all know. However, there are lingering drought issues and long-term drought issues in parts of southern British Columbia still, and very significant drought issues going into the winter in the prairie region. So there's still a significant concern as we move forward, leading to a lot of consequences for next year's drought or next year's growing season. So we have a lot of concerns at this time, especially within the prairie region. Water supplies, both surface and soil moisture, have been hugely depleted, and significant spring runoff and much above normal precipitation is required to replenish that. Okay, and I'll wrap up there. So just one quick thing, I guess, if you have any questions, my email address is there. If you have any desire to look at some of this data and information more on our website, the website address is there as well.
Awesome. Thank you, Trevor. And I do think that you answered a few questions that have come in along the way. Maybe I'll pose one to get us started, and then we might have to switch over to some closing comments. We'll see if we can sneak in two. So one of the upvoted questions that we have is, do we know, and you touched on some of how it compares to the past, but specifically, how do these droughts compare to the 1930s drought in North America, what was referred to as the Dust Bowl?
Yeah, we haven't gone that far back in terms of our comparisons yet, but we do know that the 1930s were a series of droughts, multiple years of drought, as I showed in that graph, and that has an accumulation impact, and that's why things were so severe in those years. this year's drought, quite often we talk about the single biggest drought in the last 100 years in Canada being 1961. And this year is fairly close to 1961 in terms of its extent and severity. And one of the reasons that we don't see the same impacts that we would have in 1961 from a drought that happened this year is agriculture practices and management practices have changed so much, and water conservation has changed so much that we have been able to lower the risk of severe drought impacts in some of these regions. Not saying that there wasn't any impacts. Obviously, we talked about huge impacts, but again, very comparable to 1961. Probably worse than the dirty 30s because this is a one-year drought at this point, whereas the 1930s were multiple years of dry and drought conditions back to back.
Right. Yeah, just so many pieces coming in. So I am going to sneak in one last question before we move into some closing comments. And we might, I'm going to do my best. You might keep the line open because there's a lot of questions coming in at the end that we won't be able to get to, but maybe perhaps I'll end with a question around the modeling. So the question is, do you model the probability of multi-year extended droughts? And if so, what is the current risk for Western Canada?
We haven't run a model. We've done predictions on what the likelihoods are in terms of multiple years of drought, and they're fairly low, in fact. However, this year is set up to be one of those years that is likely to move into a next year drought. We do a little bit of forecasting as well. With the current La Nina situation, we would expect higher than normal snow cover for Western Canada and colder than normal temperatures. We haven't seen that develop as much as we would like to yet. That would be a typical La Nina situation, but as we saw last year, not all La Ninas are the same. Some of them are very dry, the weaker ones. And this one's stronger than last year, but not real strong. So we're still in the situation where the probability of moving into next year's drought is still uncertain. The real challenge, I think, is we're going to a situation where our soil moisture and our water supplies are so depleted that even if we get good normal precipitation through the next 6 months, we're going to be starting in a deficit, and we really need to respect that deficit and prepare for a dry year just in case.
Well, it's, yeah, definitely something we can't stop thinking about in the short term. And yeah, really appreciate your comments. So thank you, Trevor, for your time and spending it with us this morning. I want to thank you, everybody who's sending in questions, the amount of, including the chat, the level of engagement to start off our workshop is phenomenal. I'm going to move it now into some closing comments so that we're all prepared to move together. I do want to encourage you, especially if we haven't been able to reach your questions, to please reach out to BC ACARN and we'll do our best to follow up and connect you likewise. If you would like to continue the conversation and stay connected with ACARN, you can do so on our LinkedIn page. And to help us further on this discussion, also follow us on Twitter. We really look forward to engaging with the community we've brought together today. And thank you, Faron and Trevor, for presenting. And thank you to everybody who took the time to join us for this session. We hope that you will come back with us in about 19 minutes time at 10:30 this morning for the Extreme Heat and Drought Impacts and Adaptation panel, where we will actually have a chance to hear from 4 producers from across BC about their experiences this summer and what is needed to increase resilience as we face more of these types of heat and drought events, as we discussed this morning. The login link for that session is available through the event page. I know that's been shared in our chat. It might be able to be shared again just now. And then tomorrow and Thursday, you can also join us for our morning sessions on both wildfire and carbon sequestration. So thank you again, and I hope to see you guys after the break.